Hello, everyone. So congratulations to all of you for getting through the first portion of this class. This past Tuesday, you had your modules 1 and 2, or units 1 and 2 exam, and I will be grading those exams this upcoming weekend. Today, by the way, is the 29th of September. So tomorrow is the 30th. Tomorrow I'll be playing this video recording and talking about this chapter with you. And then I'll be grading your homework. I'll be grading your exams this weekend. And then next Tuesday, I'm going to be working on a program that I'll also have set up as a video recording for you guys. And I'll play it in class and then talk about it like I've done the entire term thus far. Okay, and that'll be the way I play the rest of the term out. All right, so let's not show me, but let us instead show my screen. So today we're going to be covering chapter 4, right? So we don't need to worry about going into the content at this point. I don't want that thing to be hiding. Actually, that's all right. So let me hide that thing. So let me go over here and go into my desktop. This is just for me. You guys don't need that. Not to worry about that. MDC, Fall, Homestead, 1334, PowerPoint. Okay, and we want PowerPoint chapter 4. All right, so now let me go slideshow. I should just do function 5 to start her up. Okay, all right, so what are we going to be doing in this chapter? This chapter covers control structures. Okay, so let me begin by telling you what chapters 2 and 3 included, in case you forgot. They were called sequence structures. Sequence means you go in sequence from A to Z, or from 1 to 10, whatever. Where when we made our programs, the program always starts obviously with your pound include statements, then you're using namespace standard, then your int main. And in int main, if we had 25 lines of code, the program started with the first line of code, went to the second, went to the third, went to the fourth, and finally got to the 25th line of code. Everything was done in order, okay, in order. That's not a very effective or a very efficient way to write code. Okay, especially, of course, when the code involves a lot more data, a lot more information, and a lot more options. In those cases, we want to use a different programming style. This style is called a selection coding style. Okay, with selections in chapter 4, we have 2 different things we're going to be doing. We're going to be doing if statement logic. Okay. And we're going to be doing switch structure logic. If statements allow us to use Booleans. Booleans, remember, are true or false, with an expression, what we call a logical expression, with the term if, and if will always be in lowercase. And then we're asking a question. Like if, as an example, age greater than equal 21. Okay, then we would go to a new line, and then we would put some kind of a statement. That means if that line of code was true, then go into this statement, and the statement might just say, be a COOT statement, less than, double quotes, congratulations, you are old enough to vote. Please be sure to do so. Then we can have an else statement that would imply if the first statement, the expression saying age greater than equal 21, if it was false, then it doesn't read that first COOT statement. It goes to the else statement, and then the else statements are run. Okay, so in other words, we're not going just solely in order anymore. We're using logic and logical expressions with if statements, sometimes if else statements, sometimes if else if statements, but nonetheless if statement logic to allow our program to be more efficient. Okay, and the switch structures are also part of selection controls. switch structures are similar to if statements, and I'll talk about those a little bit later on in the chapter. All right. So as always, I won't go slide by slide. I'll just kind of talk about things as I see them, and mainly it's the first 2 or 3 slides that I'll be talking about rather than every slide, because when it says in this chapter, you will learn about control structures, examine relational operators, discover how to use the selection control structures, if else, examine int and Boolean data types and logical Boolean expressions, examine logical operators, and explain how to form and evaluate logical expressions. That's part of the objectives for this particular chapter. Okay. Then also learn how relational operators work with the string type. Become aware of short circuit evaluation. Learn how the conditional operator works. Learn how to use pseudocode to develop, test, and debug a program. And learn how to use a switch statement in a program. Switch statements are similar to if statements. And learn how to avoid bugs by avoiding partially understood concepts. And learn how to use the assert function to terminate a program. So now let me go back to the first of these two and start talking about them. All right, so control structures. I said that in chapters 2 and 3, what did you do? You used sequence. Everything sequence means we did everything in order, as I mentioned. If there's 23 lines of code in a program, we started at line 1 and went through line 23. There was nothing skipped, nothing, everything was just done line by line. All right. Now we're going to talk about the next type of control structures, and a much more important one, which, well, really ones, because one is the if structure and one is the switch structure. It's all about making a choice. Okay, so we want now the program to make choices for us depending on what we're doing in that particular program. Makes the programs much more efficient and much more effective. Okay, all right. So examine relational operators. So now we're going to be talking about relational operators. Relational operators are things like equal, okay, not equal, less than equal, greater than, and greater than equal. So what are they all? Well, so you've used the equal sign when we do statements like, let's see, num1 equals, let's say total equals, and then num1 plus num2. So total equals, that's one equal sign, num1 plus num2. What happens, with assignment statements, we are assigning from the right side of the equal sign to the left sign. So the sum of num1 and num2 are added together, and then we assign that total to the variable called total on the left of the equal sign. But in relational operators, we use equal. And with equal, we're trying to determine if two different numbers are equal. So we would say, as an example, with the if statement, if num1 equal num2, then we could have a little coot statement. Those two numbers are equal. And that could be the whole if statement if we wanted it to be. Or we could have an else. With an else, then it could be if num1 equal num2. That means if that is true, then the next line of code would be a statement saying something to that effect. So coot, less than, the two numbers are equal. Okay? But if they're not equal, if one is 10 and one is 12, that's not equal. So then it would bypass the true part of the if statement because it wasn't true. And if you have an else, that amounts to being the false. Okay? So then under the else, you have another coot statement. The numbers are not equal. Okay? And obviously I'm going to demonstrate this in one of the programs I build for you guys for chapter 4, and that'll be done next Tuesday. And I think I said I think it's October 5th if I didn't say. Anyway, so that's equal. Then there's a not equal, and not equal is an exclamation equal. Okay, an exclamation equal. And with exclamation, it means not, and then equal obviously means equal. So in that case, if we were saying something to the effect of if num1 exclamation equal, which means not equal, okay, num2, then again, a Coutts statement, numbers are different. Okay, else we could have, if we want, the numbers are the same, right? But not equal means exclamation and an equal sign. Then we also have less than. Well, less than is pretty easy, right? If num1 is less than num2, then the Coutts statement would say num1 is lower or num1 is less. Of course, we can do a lot better. We can capture the value and say what the number is, and then say is less than what the other number is. There's lots of things we can and will do. But the point is, it's just always we're talking about with logic structures, we're comparing two numbers when it's relational operators, okay, two. And of course, we can also do other things, which I'm going to talk about after a while, and that's going to be logical operators, okay? But for now, we're just doing relational. So equal, equal, so that means they equal themselves. Not equal means, in terms of how you type it, it's an exclamation sign equal, okay? And then less than just means if num1 less than num2, right? And then there's less than equal, which is if num1 less than equal num2. In this case, it doesn't have to be less than, it can also be equal to. So less than equal is just less than and equal next to each other. And then there's greater than, same thing. If num1 greater than num2, then obviously the Coutts statement, num1 is bigger, num1 is larger, whatever. And if you throw it with the else num1 is not bigger, else number one is smaller or whatever. And then greater than equal, okay? So those are the relational operators. There are 6 of them. Equal, equal. Equal equals comparing two values, okay? Not equal, it's comparing two values. But in this case, it's saying only if they're not equal would the answer be true. Less than means for the answer to be true, number 1, if I do that as the example, num1 less than num2, then if it's less than and num1 is less, then that's true. Okay, if it's less than equal, then you could have num1 and num2 both be the number 6. But with less than equal, it would be true. Okay, and then greater than and greater equal. So 6 relational operators. All right, all right. So let's see. That's relational. Determine how to use the selection control structures. So when we're talking about the selection control structures, again, we could have something, if you just think about the elections, there's going to be more elections. I think it's coming on November 2nd this year. Some of the House people, like we have to vote for the House members every 2 years. Excuse me, just having my little powder protein thing that my wife gets me. All right, so yeah, so if you wanted to say something using an if logic for somebody to determine if they're old enough to vote. So maybe you'd have a variable called age, and then you'd have that little Coutts statement, please enter your age. And then you'd have a C input statement to capture the age. And then you'd have an if statement logic to determine if they're old enough to vote or not. So then you might say something to the effect, if age greater than equal 18, then a Coutts statement, please vote in the upcoming election. And if you wanted to have it with the else would only be invoked if the person wasn't 18. So if they were 17 as an example, then it wouldn't go to the first statement, which is for true. It would go to the second statement, which we would then say is, I'm sorry, you're not old enough to vote in this election. Okay, so true, false for selection structures. All right. All right, then we're going to be looking at integer and Boolean data types and logical. Again, logical means you're just choosing with true, false statements. Expressions. So logical Boolean expressions, that because they're true, false, right? So if you have, as an example, a variable called legal age, and then you have another one called age, and then you assign legal age a certain value, you examine them with logical operators. Okay, logical operators. And those logical operators are very, very similar to what we did in the first two chapters. But now, rather than just looking at a number, we're looking at two numbers, right? We're comparing things. So there's a lot we can do and will do. But logical operators anyway. Remember, relational, I just mentioned, are equal, equal, not equal, which is an exclamation equal, less than equal, greater than, or greater than equal. In the logical operators, we have an exclamation, which means not, okay, not. We have an and, which is ampersand, ampersand. And we have an or clause, which are two pipe characters, okay? The pipe characters are the lines, like vertical lines. It's the key on your keyboard. If you hit the shift and the key with the backslash, which is just the one above the enter button. So shift and that backslash and that thing on top of it is called the pipe character. And that is what you use for the or. You type that twice. And again, I'm going to demonstrate this stuff on Tuesday as well. So this is just your overview, right? So logical operators, there are three of them. Not, which is an exclamation sign. And of course, also when I go through the actual slides, this is probably now slide 15 or 20 by now, okay? So exclamation, ampersand, ampersand, and pipe character, which means or, all right? So that's what those things mean. So let's go ahead and go through a little bit now, and then I'll try to, well, let me just finish this last topic on this page, or this slide. Explore how to form and evaluate logical expressions. So to form and evaluate, well, what are we going to do? We have just some statements, right? If we're comparing logic, we're saying something like, with a logical, remember it's a not, an ampersand, ampersand, which means and, or the two pipe characters, which is or. So not, and or. So how could we use them? Well, we can say as an example, not, okay, and not means what? The exclamation sign, and then an open parenthesis, 6 less than equal 7, close parenthesis. So how would that evaluate? Well, 6 is less than 7, so that is true. But if we put a not, meaning an exclamation in front of it, then that means not less, it's the opposite. So with a not, that answer would actually come out to false, okay? That would be an example of forming and evaluating logical expressions. All right, so let's go on now. Now this one here, I'll try to remember slide 3 to come back to this one so I can go review some of those first things with you now, okay? All right, so a computer can proceed in sequence. Again, that was chapters 2 and 3. Computer can proceed selectively. That's making a choice, okay? That's what we're talking about with chapter 4. And of course, when I say chapter 4, it really means chapter 4 plus, because you'll be doing, meaning every other chapter, you'll be doing some if statement logic or switch case structure logic periodically, even if it's chapter 6, 7, and 8. You'll still be doing that. But anyway, repetitively, looping, we'll be covering in chapter 5. And I'll say again, chapter 5 plus, because we'll be doing it also in chapter 6, 7, and 8. This is just when we're going to be introduced to it. And then by calling a function, that is chapter 6. Okay, 6 is going to be calling functions and also procedures. The two most common control structures are selection, using if statements primarily, but also switch structures, and repetition, repetition meaning do loops, for loops. They're the two big loop styles, okay? All right, so now control structures here. So sequence is A. So A, what did it do? Statement 1, they're calling it statement 2 to statement N. Just call it line number. Line 1, line 2, line 3, line 4, line 44, line 45, and then it's over. What I said at the beginning, this is what we did in chapters 2 and 3. We started at the first statement and went line by line by line by line. All right, now selection. This is chapter 4. So there's an expression. Again, we could say age greater than equal 18. Okay, think of that as an expression. So age greater than equal 18. Now, obviously, we would have had to declare age in this case as an integer. All right. So if it's true that the person, meaning the age, is greater than equal 18, then it comes to the true side of this diamond. Okay, so the true side. And statement would more or less say, oh, you're over 18, or yes, you can come in, or you are old enough to vote, or you are whatever. Okay. If it's false, though, that means then they're not 18, so it would come to statement 2. See, this is what it means by selection. It's either true or it is false, one or the other. It can't be both. So you're either on the true side, in which case there'd be a statement, or the false side, in which case it would be a different statement. Okay, and then it comes down to the end, or to the next line, if you will, in the program. So it may bypass. In this case, there may be 2 or 3 other things besides statement 1. In this case, there may be nothing else besides statement 2, right? But that's why we're saying selection as opposed to sequence. It won't go now line by line. Now, what's the difference between selection and repetition? Well, look over here on the third little picture, if you will, on the right side of this screen now. So here we have the same expression. Let's say age greater than equal 18 again, all right? So if in this case, think of many people are putting in their age in just a little program, all right? So if it's true that they enter 18, all right, it'll go back to the statement and go again. And this is the loop. It's going back up here, and then the next value would be reviewed. If it's true, it goes to the next, it stays in the loop, comes back up here, goes to the same expression. Is this next value also greater than or equal 18? And it'll go, 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 go until at some point it's going to hit a false. And if it hits a false, then that's how it gets out of the loop. All right. So that's what's going on with control structures here. So an expression that evaluates to true or false is called a logical expression. You can say 8 is greater than true. Well, that's either true. 8 is greater than 3. That's either true or false. They put it in quotes, right? So what that means, it doesn't spell it out, but what that's saying is 8 greater than true? All right, that's what the statement would be. But if they put it in this fashion, 8 is greater than true, then by default, that is true, okay? Otherwise, if it was, let's say, 2 is greater than 3, it would be false. So remember, expressions have to evaluate to true or false, male or female, 18 or older or not. Okay, things like that. Relational operators. So equal, equal, and the description, that's the operator. The description is equal to. Now, remember our first equal. We've used equals, right? All in chapter 2 and all in chapter 3. And we're going to continue to use equal signs, meaning one equal sign, all the way till chapter 8, all the way through chapter 8. But in this case, it's a relational operator, which means what it's doing is it's comparing two values. Everything here is comparing something against something else. So in this case, we're not assigning with the equal sign. Instead, we're using two equal signs to compare. And we're seeing if it's equal to something. All right? All right. And then not equal, I told you, is that exclamation equal sign. So you have to type 2 characters for the equal, 2 characters for the not equal. Exclamation means not, and of course equal. So in that case, what? Again, not equal. So if age not equal to 18, well, that wouldn't be a good way to use not equal. Because why? Well, you can still be 19. That's not equal. You can be 20. That's not equal. You can be 10. That's not equal. 1. That's not equal. So, you need more specifics, but depending obviously on what you're trying to do. Less than, it's just the less than sign by itself. And obviously that means one thing is less than something else. Less than equal, it's the same as less than, but you can also go up to equal. So in this case, less than, so if you're saying that a number is less than, let's say, the number 10, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 would apply, and any number that you put a negative sign in front of would apply. But in this one, but not the number 10 itself. only less than 10. And this one with less than equal, it could also be the number 10. Or so 10 or smaller in this case if we're looking at 10. But if in this case, if it's less than 10, it means really 9. So the only difference is one extra number would fit with the less than or equal. Oops, sorry about that. And then greater than, opposite obviously of less than, right? And greater than equal, opposite of less than equal. So each relational operator is a binary. It means it requires two operands. Two operands are just two choices, two numbers, two things you're looking at. And expressions using these operators always evaluate to either true or false. And that's what you need to understand, because we're going to be doing this over and over again, for the rest of this class. So you need to understand that when we are comparing things, we're comparing to Boolean values. True and false are Boolean. Officially, there are numbers for these things. True is the number 1. False is the number 0. Which means there's also, remember I talked about logic errors quite a few times in this class now? And so logic error is where, your code syntactically is correct, but logically it's giving a bad answer. And I mentioned once or twice an example if we're saying that you have a form or you're asking for user input and it's either English or Spanish or Creole or whatever languages I might have said. If you click a button that has English, you expect to see then the typing or the writing, in English, right? So that it would be a logic error if it was not. So expressions using these operators evaluate the true, false, understand that. And logic errors are things where we're making a mistake because of the way we wrote our code. And especially with things like not equal to, that's very confusing for most people. I do not ever write any code with a not equal. I don't like it. Because just think again, if we had something in this line saying more or less 6 is less than 7. Well, logically, yes, 6 is less than 7. But if you're saying 6 not equal 7, it throws my mind for a loop because it's hard for me to think in that kind of, I call it ill logic, right? This is logic. 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 But not equal, I don't like it. So you can normally phrase these kinds of things in a different way to turn them into equal to, right? But it does depend on what you're doing. But anyway, it is a valid expression. All right, so here's some examples. 8 less than 15. Well, that's the expression. This is computer expression in C++. So 8 less than 15, 6 not equal 6, 2.5 greater than 5.8, 5.9 less than equal 7.5, 7 less than equal 10.4. All right, so we have these values. So the first one, it means 8 is less than 15. Well, in this expression, is 8 less than 15? Well, let's see, 8 less than 15. Yes, it is. So it would evaluate to true. Okay, so if we were doing it in a program, we would say if, and then there's always the open parenthesis, 8 less than 15, close parenthesis, and you don't put a semicolon with if statements, okay? You would just go into the next line of code, go down to the next line of code, and then let's just say you'd put a COOT statement saying 8 is less than 15 is true or some such thing, right? 6 not equal to 6. Well, 6 is not equal to 6 is what it means, and that's false because 6 equals. So when you're using a not with an equal, it's good to pretend it doesn't have the not first. So, right? Like if I say that not is not here, then what's there? 6 equals 6. So 6 equals 6. Is that true? Of course it's true. So if you see a not, it means automatically it's false, assuming the other was true. Okay? All right. 2.5 is greater than 5.8. Of course it's not. So it's false. 5.9 less than equals 7.5. Of course it is. It's true. 7 less than equal to 10.4. It's true. Now don't think this stuff will be on any upcoming test. This is very, very easy. This is just an introduction, a simple introduction to relational operators. It will get much more complex even in this chapter. Okay, in this chapter. All right. In an expression of char values using relational operators, relational, remember the same ones we just did, equal, equal, not equal, less than equal, greater than equal, okay? But when you're using char, remember I told you everything is based upon the ASCII code. I said like if you hit the space bar once or twice in class, I said that's technically ASCII code of 32, which means it's a 001 and then 5 more zeros. That's how you really ultimately get answers in the computer language. In a programming language, it gets it at the machine level, which is the first layer of the old OSI, Open Systems Interconnect model. Anyway, so, but expressions of char just means, remember, you're comparing one character. One is the key. And everything that's char has a single quote, like the single quote, capital R, single quote, capital T, single quote. They're char values, okay? You can't say and R. It would either have to be R with double quotes, in which case it's a string, or single quotes, in which case it's a char, all right? All right, return an integer value of 1 if the logical expression evaluates to true. This is, I think I mentioned a few minutes ago, that true technically, in terms of the answer, it evaluates to a 1, okay? And if it's false, meaning it's not true, then it's a 0, okay? All right, so now most of the things we'll be doing will be two-way selections, but there's a one-way selection syntax too, and you can actually use one-way for a lot of things. But you see the example, if, and there's an expression, and then there's a statement. But do you notice how it is? The if is lowercase. Remember everything in C++, just like C# and Java, Python, everything is case sensitive. Only Visual Basic is not. So it's lowercase if, a space, open parenthesis, close parenthesis, and you do not put a semicolon at the end of the if expression. It can only be at the end of the statement, okay? So the statement is executed if the value of the expression is true. So again, let's just say that same little thing. If age greater than equal 18, all right, that would be the expression. That's either true or false. We saw that in 2 or 3 slides now. It's true or it's false. So let's pretend it's false. If it's false, this statement will not read, won't be processed by the computer. What happens is that it is actually processed, but it would then be skipped. There wouldn't be any answer, any statement or anything to happen unless there's then an else under it. And there doesn't have to be. This is called a one-way selection syntax. So it means it's either true or false, but you don't have to have an answer either way. This is, if it goes to this statement here, that would be indented right here. That means it's true. If it does not go there, it was false, and it would then go to the next line of code. All right. So the statement is executed, if the value of the expression is true, it's bypassed if the value is false. And then the program goes to the next statement. The expression is also called a decision maker, and the statement following the expression is also called the action statement. So if is a true-false statement, it must have a true-false answer. Must. Okay, must. And then the statement is optional, but it's executed. I mean, you know, if it's going to be a true statement, you definitely need something to happen. All right. All right, so one-way selection, just say the same thing. Just pretend this is the age greater than equal to 18. If it's true, congratulations, you can vote this election. If it's false, sorry, you're not old enough yet. I hope you can vote next year. Something like that. All right, now two-way selection syntax, much more logical to use, much more common sense to do it with two statements, because this way you're covering both answers. It's either true or it's false. So if the expression is true, it doesn't have to say if is true. Like you can actually say if, open parenthesis, age greater than equal 18, okay? And if you want, you can say equal true. Or you can say if age greater than equal 18. Either way, it understands that that means it's true if the number represents something that the expression has. And it would go to statement 1. If it's not true, so the person is 17 or less, it'll come down to the else and then the next statement. okay? And you see only one statement is executed. So if it's true, this is executed, and then the program skips else and statement 2, and it comes down to the next line. If this is false, it skips the next line, comes to the else. So it always goes, that's one, but only one of these when it's got an if and an else. So again, in a little pictorial fashion, so you put your expression, age greater than equal 18. It's true. You have some statement. Oh, congratulations, you're old enough to vote. False, I'm sorry, you're not old enough to vote. Obviously, this can be way, way better. But for this point, you know, for this, at this point, at this juncture in chapter 4, that's good enough for us. All right. All right. So now, int data type. All right, and logical expressions. So we understand that there's an int data type, and an int data type is just a number. Remember that logical expressions evaluate technically, we say true, false, but true is 1, false is 0. But we will always in this class use the values true or false, okay? But there's logic errors when you're evaluating things to 1 and 0, because if you're comparing it to an integer value, then that can be a problem. All right, that can be a big problem. So logical expression value was stored in a variable of the data type integer, meaning int. You can use the int data type to manipulate logical Boolean true false expressions. Excuse me. The data type bool, which is Boolean, has logical values true, false. We know. Bool, true, and false are reserved words in C++. The identifier true, I told you, has the value 1. You know that now. The identifier false has the value 0. It's easier to use them in terms of true, false. All right, so we did the relational operators. Remember, that was equal, equal, not equal, meaning exclamation equal, less than equal, greater than equal. Okay, so that's our choices. Now we're over in logical operators. And logical operators, we're still on that first slideshow. See, we're on slide 16 now. That I think was the second slide actually talked about the objectives 1 of 2. Like this says whatever here, 1 of 5. So 1 of 2, and then there's another 5 or 6 or 7 I got to still cover, and there may be 1 or 2 more in that first one. But I remember this one was one of them. So logical, meaning Boolean, which is true, false type things, operators. So not is an exclamation sign. Ampersand, 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 they have to be butted up against each other. That means and. Or, I told you, is that pipe character is what we call it, but it's above the enter key, and it's on that key above it, there's 2 characters. The lower one is a backslash. Backslash starts in the top left and goes to the lower right at an angle. And then if you did the shift key instead, you would, with that same key, then you get the pipe character. And the pipe character, if you're looking on your keypad, your keyboard, some keyboards show it as like 2 separate lines each, but doesn't matter. That is the pipe character. Okay, so in the one they're using, which is like one of my computer keyboard, it's a solid line, solid vertical line. And then you have to use 2 of them, and that means or. Okay, so it's important to understand or versus and versus not. All right, so the not operator, though, is one that I don't like, as I said to you. So true, non-zero is false. So an expression, if it's a non-zero number, because true is the number 1, it's false. False 0, okay, is in fact right, because that's true. So false 0 is going to evaluate to the opposite, which would be 1. Now here's a good example, and there's going to be quite a few of these good little examples. So you see the not. So let's first do it without the not. So if you say A is greater than B, and you can tell they're chars, right? Because it's a single quote before each. So A is greater than B. What this means is in the ASCII world, and I'll just tell you that a capital A is about a 65 or 66 or 67, okay? I don't preview these things, but it's in that range. And it is the lowest number for a capital letter. B is 1 higher than A. So if A is 67, B is 68. If A is 65, B is 66. So therefore, A is not greater than B. It's one number less than B. So here it would be false, okay? But then, because I said always start with the pretend the not is not there. So A is greater than B is actually false. But if you flip it to make it not, well, A is, so with the not sign, then it is true, okay? Maybe their explanation is better than mine. So because A is greater than B is false, and this is false, truly false, then not A greater than B is true. That's the logic, okay? Not 6 is less than equal 7. So again, pretend it doesn't have the not. So is 6 less than equal to 7? Of course it is. So it would be true, right? But with the not, you know it has to be false. It's got to be the opposite of the other value. So because 6 is less than equal 7 is true, not 6 less than equal 7 is false. All right? All right. So now we got the ampersand operator, okay? And the ampersand operator is the and, all right? So for and, you must have two expressions that are the same. So if this one is true and this one is true, then the expression is true. If this one is true, this one is false, then it can't work because ampersand and means both are the same. So that would be false. Here, false and true, that's no good. It has to both be one or the other. Here, false and here's false are true, are false. And this is because, again, it's getting into the harder part. Because false 0 is right, but false 0 really implies 1. So one of these would be read as true and the answer would be false. And that's because, remember I told you a true statement, the word true is 1. The word false is 0. All right. So here's a few others. 14 greater than or equal to 5. So we know that's true. But with an ampersand, that means and A less than B. So 14 is greater than or equal to 5. The answer is true. A is less than or equal to B. I told you A is like either 65, 66, or 67, and B is one more. So A is in fact less. So both of these are true. And the explanation, because 14 is in fact greater or equal to 5, that's true. And A is less than B is also true. And then true and true, because there's two different statements. This is true, this is true. So true and true is true, and the expression is true. 24 greater than or equal to 35 is false. And A is less than B is true. So here we have a false and a true. So that means false because they have to both be the same, right? So false, because 24 is not greater than 35. So therefore 24 greater than or equal 35 is false. A is less than B is true, but false and true means it's false. All right? All right. Or operator, that's the pipe character. Same logic. So same, it looks like the very same numbers even. So here, 14 is greater than or equal to 5, or, the two pipe characters mean or A is greater than B. Well, this is true, and this is false, right? But in the case of an or, that means one or the other. You don't need to have both. So this is true, this is false, that means it's true, okay? 24 greater or equal 35 is false because it's less than. A is greater than B is false because it's less than. So here we don't have either. This is false and this is false, so the answer is false. All right. Let me look at my time. It's 15:13. I think that means I'm at about 45 minutes. I need to start winding this up. Shoot. All right, I'm going to skip, but so you know what they're doing, but please review these, okay? Order of precedence. So order of precedence means, you know, the way we have to associate things, just like I talked about in the first, in chapter 2 or chapter 3 when I was talking about like division and multiplication are ahead of addition and subtraction. And anything within parentheses is above both. Well, you also have order of precedence in relational operators here as well. So the first order is the not, the plus, and the minus. They're unary operators. Unary means there's only one thing that you have to have in it, not two operands. Second is the asterisk, meaning multiplication, the division, and the percent, which means modulus, if you remember. Third is the plus and the minus. Fourth gets to relational operators, less than, equal, and greater. Fifth is relational operator equal, and not equal. Okay. Sixth is the ampersand, which is and seventh is the or, the pipe character. And finally, the equal sign, the single equal sign, which means the assignment. Okay. All right, so suppose you have the following declarations. Bool found equals true. Int age equals 20. Double hours equals 45.30. Double overtime is 15. Int count equals 20. Char ch equals b. I'm not going to be able to go through all these, so I may not even be able to remember this in the next one. All right, so not found is false because found is true. Remember, with anytime you have a not, just take the not off. Is found true? If it is true, then the not is false. Okay. Hours greater than 40. Well, that's true because hours is 45.30 from the previous page. Not age is false. Age is 20, which is non-zero, so age evaluates to true. Therefore, not age is false. Remember, not. It's always the opposite. I'm not going to read these. You can read them. Not going to read any of these. You can read them. Relational operators and the string data type. So we're also in chapter 4 going to now start comparing strings. And remember I mentioned that when we did the string in chapter 3, we would be doing a lot more with strings, real string manipulation. That's what this chapter is all about. So let me read this one. So relational operators can be applied to variables of type string. Strings are compared character by character, starting with the first character. Comparison continues until either a mismatch is found or all characters are found equal. If two strings of different lengths are compared and the comparison is equal to the last character of the shorter string is less than the larger string. So let me show you some now, or they're going to show us. So you have to, so say we are declarations again. I won't be able to remember these by the time I get to the next one, but anyway, I'll just try to do the ones with numbers. So int age is 20, hours is 45 and a half. 20, 45 and a half, overtime 15. I won't remember that. So, all right, string 1 less than string 2. This is probably easier. So, string 1 equals hello, and string 2 equals hi. Okay, so now here's the comparison. Is string 1 less than string 2? All right, so how do you compare? You compare character by character. So the first one, string 1, starts with a capital H. The second one, string 2, starts with a capital H. So they're equal. Okay. Then you go to the second character. String 1 has an E. String 2 has an I. Okay. So we don't need to go any further. String 1 is less than string 2 because an E has a lower ASCII value than an I. I told you the capital letters, 65 or so for an A. With lowercase, it's about a 97 for an A. Therefore, an E, though, is about a 101 or 102, and an I would be about 106 or 107. So this is true. All right. String 1 greater than hen. Well, string 1 is hello. Capital H. This is a capital H. It's equal. E. It's equal. But here there's an N, and here there's an L. N is a higher number in the ASCII world than an L. So the answer, string 1 is greater, is false. You read the rest of it. String 3 less than un. So string 3, string 3 is air, A-I-R. So again, capital A. N is not less than, N here is a lower number. So therefore, string 3, though, is what we're comparing against. So the I is higher. The I, the second character, is lower than N, the second character. So string 3 is, in fact, lower. So it's true. Okay. So you can continue to do those. Okay. String 4, Billy. 4 characters. So in this case, string 4 is Bill, okay, and then the other one is Bill Lee. All right, so string 4 is B-I-L-L, B-I-L-L. Remember, the case sensitive, so capital it counts as well. It is 4 characters, and Billy has 5. Therefore, string 4 is the shorter string because the fifth one is going to be about an ASCII 120 something, and nothing is nothing. So therefore string 4 is not greater than, it's less than because of that last y. All right, you can look at that one again. So compound statements are blocks of statements where you have more than one thing within a block of code. Remember, a block starting with an open curly, closing curly, and in this case, that, right? So let's look at what they're saying. So if age greater than 18, it should be greater or equal probably, but that's all right. So if age greater than 18, coot, eligible to vote, and another statement, no longer a minor, all right? That's fine. Else, they're not greater than 18, but they might be 18, so not eligible to vote, still a minor, okay? When one control statement is located within another, it is said to be nested. An else is associated with the most recent if that has not been paired with an else. So over here, we have if and then some else ifs. So if score is greater than or equal to 90, the grade is an A. Else if score is greater or equal to 80, the grade is a B. Else if score is greater or equal to 70, the grade is a C, then a D, then an F. All right? Now look at this logic. So score greater than or equal 90. It's very important to understand the way this example is going. It's starting with a high number. Why? Why? This is why. Pretend you start with a lower number. So anything that's not at least 60 is an F. So let's say you type a 0. So if you put up here, if score greater than or equal to 0, the grade is an A. Else if score greater than or equal to, it's a B, C, D, F, right? See? So what you do is you have to start with the most difficult. For some of you, getting an A is easy, but in terms of scores, it's the most difficult still. So think of the logic now. So if the score is 90 or higher, that will be an A. Then if it's not true, remember it won't go to this statement, it'll go to the next line. Then the next one's another expression. Else if score is greater or equal to 80. It wasn't 90. Maybe it was 89. 89 is greater than or equal to 80. So that's a B. Maybe it was only an 80 or 81, but that's still a B, right? But if this one is false and this one is false, it goes to this one. Else if score greater than or equal to 70. If that's false, it goes to this one. Now it's 60. And if that's false, it goes down to the F, right? Logic. Okay. Comparing if-else statements with the series of if statements. So if month equal, remember, equal would only assign. This is comparison, so it's relational. You need two equal signs. So if month equal 1, then they're saying, okay, that's January, all right? Else if month equal 2, then that's February. And then 3, 4, 5, 6 for March, April, May, June. So that's what they're showing in A. Then in B, instead of if-else, they're doing a bunch of ifs. And you can do this too, unless I say you can't. So like here, if month equal 1, coot January. It's either true or false. If it is true, then it's January. But see, there's no else, which means what it would do is, in this case, it's just the single. Remember, there's single expression and then 2. And in this case, it's only a 1. So it's either 1 or it's not. If it's a 1, it's a January. If it's not a 1, then if it's a 2, then it's February. If it's not, here. So you can do it from the previous, if, else if, else if, else if, else if, else if, which is probably the way you'll do something on an exam, or at least you might. This logic, oops, let me just hit the next, versus this logic. Same answer. It's just what one makes the most sense for you, and that doesn't mean that's what you'll be doing, but either way, that's just showing you. All right. Now, short circuit evaluation just basically means you're having a logical expression and it stops as soon as the value of the expression is known. All right. So I do not like these expressions because age greater than or equal to 21 is fine, and the or is fine, but why x equal 5? What in the heck? They're illogical. They don't make sense. Grade equal A, that's fine. Ampersand x greater or equal 7 makes no sense. So I can't understand that logic, okay? But the bottom line is, let me go back again. The bottom line is if age is greater or equal to 21, it doesn't read this one because it's an or. because it's already true. Remember, only one has to be true, and that's what short circuit means. The expression, the evaluation stops as soon as the value is known. So this is either true or false. So if this one is false, then it has to go to this one. Then if this one's false, then the whole thing is false. If this is true, it doesn't need to go here because the whole thing's already true, because that's an or, not an and. If this is false and then this is true, it's still, this is true, then that also evaluates to true because this is false or this is true. So then the true would win. All right. All right. Comparison of floating point numbers for equality may not behave as you would expect. 1.0 equal. Remember, equal means compare. 3.0 divide by 7 plus 2.0 divide by 7 plus 2.0 divide by 7. And they're telling us that evaluates to false. Why? 3.0 divide by 7 plus 2.0 divide by 7. Okay, they're saying that if you put all that in your computer, it's actually I don't remember what it's called because I'm older than you guys, but when something returns the same number all the time, in the old days we used to put a line above it. That basically means it's going to be 9s forever. Well, actually it's not, because here's an 8. I think that's probably really a 9. But anyway, it doesn't matter. This is not 1 is the point. Okay, so 1 is not 0.99999 because it's comparing the actual, and that is off just by a tiny bit, but it's not. All right. Okay. Here's associativity of relational operators. So here's a little example that you can put into your own computer for now. So let's see. So IOStream namespace standard. So we got a number, enter an integer, and then that's going to return as num. And then we're going to go to a new line. If 0, so if 0 is less than or equal to the number num, which is less than or equal to 10. What that means basically is that your number is between 0 and 10. So the number, and then that means they would put what the user entered. So you can play a little game with your friends or your mom or your dad or whoever on this. So it just basically means if you put the num 1, then it'll say the if statement would read if 0 is less than or equal to 1, which is less than or equal to 10, then the answer is 1 is within 0 and 10. Yeah, I like this example. Actually, it's good. Else, that means it's not. So maybe the number, let's say, was 11. So else 11 is not within 0 and 10. Yeah, that's a good example. Look at that one. All right. Associativity of relational operators. Again, a precaution. Where are we? I think I'm winding down time, and I still got 15 slides. I got to keep going. You can look at this one, but it's probably going to be similar to the other one, but just be careful, okay, with everything. Avoiding bugs by avoiding partially understood concepts. So this is just talking about if you don't understand something, then don't do the darn something. You know, make sure that you understand it first. Otherwise, you're going to have lots of logic errors. Logic errors is what they're trying to get at, okay? Input failure in the if statement. If an input stream enters a fail state, all subsequent input statements associated with that stream are ignored. Program continues to execute. The code may produce erroneous results. Use if statements to check the status of the input stream. Oh, okay. Yeah, this is good. You won't have it in this class, but that just basically is saying, obviously, you want to make sure that something is good or not. Remember when we had the file.open that I introduced in the last class, in file? And we opened a particular file, a text file, and then we created an output file. So you could have if statement logic to see if that input stream is still open or if there are more items in it, okay? Just to make sure it doesn't run into a fail state. So that's a good thing too, but it won't be needed in this class. Confusion between the equality and the assignment. So here they're saying if x equals 5. Now if x equals 5, remember that's an assignment statement. So the 5 is now assigned to the x, right? So x is 5. Then the COOT statement, the value is 5. You know, it's just kind of, it's confusion. This is typed out, but the real thing is the appearance of equal in place of equal resembles a silent killer. Yes, that's true. Because you would not normally have an assignment within an if statement. You would be saying if, and then x equal 5. The value is 5. That's what you want, not to assign it over to it. All right. Conditional operator. You won't have these in this class either. This is just talking about some things where if you're looking for a value and you normally are doing it with if statement logic, so you could have something to the effect of, well, the expression here, actually, good example. So max equals A greater than equal B, question mark. Question mark is called a ternary operator. It's really a conditional operator. It's a question mark. And then A colon B. It just means that you're looking at that number to see if it is in fact going to apply with this max number that we have over here. So this is fine, but we won't be doing it in this class. Program style and form, indentation, obviously just talking about, well, let's see. A properly indented program. We always talk about, well, we don't really always talk about it in this class, but I've told you it's always good to put comments, right? So properly indented programs help you spot and fix errors quickly. Shows the natural grouping of statements. So insert a blank line between statements that are naturally separate. 2 commonly used styles for placing braces. You know, braces like the curly braces. On a line by themselves is what I like to do. A lot of people put the left brace, like if you look at int main and you do it through REPL.it, the opening curly brace is going to be to the right of int main, and then the right closing curly brace is on the line by itself at the end. So that's what they do. I prefer a line by themselves. Pseudocode, just an informal mixture. You know, pseudocode is like you're trying to create a program and you're just writing down thoughts to yourself. And with the pseudocode, you're just writing down things to help you understand what you're going to be writing. So it's a real good idea, okay? And it helps you quickly develop the correct structure of the program and avoid making common errors. Now, switch structure, last thing, and then we got to stop this. Switch structure is an alternate to if-else. And you see here, there's a switch structure logic. So I may not even have to go any more slides to show you. And I think there's only about 9 left after this, and 3 or 4 will be a review. So you can do the review by yourself. So switch structure is an alternate to if-else, right? Switch, which is an integral expression, is evaluated first. So up here you have an expression. Let's say the expression can be, you know, letter grade or numeric score, you know, whatever again. And then the case will be the choices. So let's pretend that it's for numeric grade. So this is up here, numeric grade. And then if the first value is like greater than or equal 90 or something, then you're looking at that number. Is that in fact greater than this? Greater than or equal, meaning this is true. If it is, it'll come to this statement here. And the difference, the real key difference is though we put breaks, because case structures, if one is true, if you don't put a break, it's going to go to the next case. Okay, so if this one's true, even though it's not going to do anything bad necessarily, unless you have logic errors, it's good to put break with a semicolon after. And by the way, look at when it says value 1, it's a colon. That is not a mistake. That is a colon. All right, and there's no semicolon, just like with the if statement. Switch and the expression, no semicolons. That's exactly the same as like if, open, parenthesis, expression, close. Then you have your open and close curly, and then within it, whatever you want to do code-wise, but each case would have a colon at the end of the value, whatever you're calling your case, and then the statements, obviously, for if they're true, and you should always have break. As a matter of fact, it's probably required. I don't remember now, but anyway, break, semicolon. No, it's not required, but you should have them there. All right, so that's good. And then here is just giving you an example here. So you have your expression, let's say 90, you're looking at a numeric grade, and if the value of it is greater than or equal to 90, it's either true or false. If it's true, okay, then statement, you made an A because you're basing it on 90 plus. False, was it greater than or equal to maybe 80? Same thing. Okay, great, you made, or good, you made a B, then C, then D. And then a default. The default is like else in the if world. It's just, well, in case people screw up and put something that's not what I'm expecting. So in effect, it's like an error condition, and just put, no, that's not a valid number. No, that doesn't make sense for this program, something like that. All right, one or more statements may follow a case label. Braces are not needed to turn multiple statements into a single compound statement. When a case value is matched, all statements after it execute until a break. This is what I was getting at. When a case value is matched, all statements after it execute until a break is encountered. That's why it's good to have break. Okay. The break statement may or may not appear after each statement. See, may or may not. You normally want it after each because you're trying to base it on then the program goes to another section. It passes this. And again, remember, we're not doing sequence anymore, line by line. So we like the idea of the if statements because they're true, false. They are only going to go to the one that evaluates as true. Switch, same logic. We want to make sure that they're all evaluated. But if we use a break, then when it hits one that makes it true, then you can break to get out of it. Okay? Okay, here's an example. So another example. I mean, just in this case, though, letter grade. See, they didn't use number like I was talking about, but grade would be a char here because they're doing single quote for case A, single quote for case B. So that's char, right? And then, so if, this is kind of silly though, really, because if I guess they're saying if you have an A in the class, that turns to a 4.0. Yeah, and if you have a B, it turns to 3.0. Default there, see, grade is invalid. So anyway, that's it. Consider whether the switch structure must include a break statement after each COOT statement. Normally it would. Okay. Terminating a program with the assert function. The assert function is good to use when things have to be ended. The only example I could really come up with would be, well, actually they have it right here, the division by 0 for sure. That's sometimes tricky. So you can use the assert function, but if you do, then you need to use a C assert header file. And with the C assert header file, you also need to use that mdebug for define. We will not be doing this in this class, so don't worry about it. And there's your quick reviews. Okay, so have a great day. I apologize if this went a little bit longer than I wanted, but let's see. Let me stop the recording first of all. Have a great day, and I'll see you in class.